In this video, we're going to be going over function composition evaluation using equations. So in previous videos, we've talked about this notation. This can be rewritten as f of g of 2. Remember, we work from the inside out. So we're first going to evaluate g's function when the x value is 2. So if I substitute 2 in for x into g's function, this would say 5 times 2 minus 1. 5 times 2 is 10, minus 1 gives me a value of 9. So if we substitute 9 for g of 2, this now says we want to evaluate f's function for an x value of 9. So substituting 9 into f's function, we have 2 times 9 minus 3. 27 minus 3 gives me a value of 24. So f of g of 2 is equal to 24. All right, next example, very similar. We have f of g of negative 4. So evaluating g's function for an x value of negative 4. We're substituting negative 4 in for x. That would say negative 24 plus 6, which is negative 18. Now substituting negative 18 in for f's function for x would say 3 times negative 18 plus 5. 3 times negative 18 is negative 54 plus 5. And so I'd get negative 49, which is my final answer. Next example, we have f of g of 0. So substituting 0 into g's function, 5 times 0 plus 5. 0 plus 5, which is just 5. Now we need to plug 5 in for x into f's function. So substituting 5 in for x would say 4 times 5 plus 2, 20 plus 2, or 22 as my final answer. Okay, number 4, we want to evaluate f of g of 2. Substituting 2 into g's function, we would have 2 times 2 plus 3, which would give me 4 plus 3, or 7. Substituting 7 now into f's function would say 7 squared minus 5, or 49 minus 5, which is 44. All right, the next example says g of f of 4. So I'm substituting 4 into f's function first. So substituting that would say 4 squared minus 5, or 16 minus 5, which gives me an output of 11. Substituting that for f of 4 leaves me g of 11. Substituting 11 into x for g's function would say 2 times 11 plus 3. 22 plus 3 gives me a final answer of 25. The next example, f of g of x. So I'm not really substituting a value in for x. I am just going to replace g of x. So we know that g of x is equal to the expression 2x plus 3. So that is what I'm going to substitute into that parenthesis. So f of g of x is equal to 2x plus 3. So all I did was I substituted the g of x for the expression that g of x was equal to. Now this is telling me to substitute this expression, 2x plus 3, into f's function. So I'm going to substitute this entire expression for x into f's function. So f's function says we take x squared if I'm substituting this expression 2x plus 3 in for x, that's going to say the quantity 2x plus 3 squared and then minus 5. All right, I'm going to expand that out. 2x plus 3 quantity squared means that I'm multiplying 2x plus 3 times itself and then subtracting 5. We do have to distribute this in order to multiply. So 2x times 2x gives me 4x squared. 2x times 3 gives me 6x. Now I have to distribute the 3 to each term. So 3 times 2x gives me another 6x, and 3 times 3 gives me 9. I'm going to pull down this minus 5. Now checking for like terms to simplify. There is nothing like the 4x squared, so I'm just going to bring that down, 4x squared. I am going to combine the 2x terms. They're both 6x, so adding those, I would get plus 12x. And then combining the two constants.
At this time, please dismiss 10th graders, last names B through H to B200 with their Chromebooks and case. At this time, please dismiss 10th graders, last names B through H to B200 with their Chromebooks and case. Thank you.
I apologize for that interruption. Positive 9 plus negative 5 would give me positive 4. So this entire expression, 4x squared plus 12x plus 4, is our answer to that composition of functions. Okay, the next example is similar. We're not substituting a value in for x. We're substituting the expression that represents f of x, which is x squared minus 5. So if we substitute that for f of x, we're left with g of x squared minus 5. This time we're substituting x squared minus 5 in for x into g's function. So g's function says that I take 2 times whatever x is representing, which is this expression, x squared minus 5, plus 3. I am going to distribute the 2. So I would have 2x squared minus 10 plus 3. And combining like terms, we're left with 2x squared minus 7 as our answer to that composition of functions. All right, number 8, again, substituting g of x's expression. First, g of x's expression is 2x plus 3. So substituting that for those inside parentheses would leave me g of 2x plus 3. Now it's asking me to substitute this expression 2x plus 3 back into g's function. So substituting that, it would say 2 times my input of 2x plus 3 and then plus 3. Distributing the 2, I would have 4x plus 6 plus 3. And combining the two like terms, I'm left with my final answer, the expression 4x plus 9. Okay, the next example, I am substituting g of x's expression, which is 4x plus 1. And I'm substituting that for g of x. So this is going to leave me f of 4x plus 1. Now this is asking me to substitute the expression 4x plus 1 in for x in f's function. So that would say 3 times the value of the input, which again, we're substituting 4x plus 1 as the input. Distributing that, I would have 12x plus 3. So that expression represents the composition of those functions. Okay, the next example and the last example, we have g of f of x. I'm going to rewrite that. So we have g of f of x as our alternate expression. This is asking me to substitute f of x first. So replacing 3x for the inputs, we would have g of 3x. Now this is asking me to substitute 3x into g's function. So replacing that x with the expression 3x, I'm going to multiply the 4 times 3x, which is 12x, and then plus 1. So this expression 12x plus 1 represents the composition of those functions.